The objective of this video is going to be able to create a VPC. So as you can see, if this is AWS Web Services, we're showing here a specific region. This region in particular is the US East 1. This is the one located in Northern Virginia. As you know, a specific region in AWS is going to be composed of several, at least 2 availability zones. In this case, we have availability zone 1, availability zone 2, and availability zone 3. The code that AWS refers to when you're talking about US East 1, or the Northern Virginia rather, is US East 1. For availability zone, for the first availability zone within that region, we're going to have US East 1A. So we're going to be adding letters to differentiate the different availability zones. So this one is US East 1A. This other one is going to be US East 1B, and this third one is going to be US East 1C. Then if we create a VPC, that VPC is going to be able to span multiple availability zones. So that's the idea, that a VPC can span as many availability zones as your region contains. Okay, that's an important thing to keep in mind. In other words, if you have a VPC, you can create multiple resources in different availability zones. And then, so if you have, as I mentioned before, if you create a VPC in a specific region, in this particular case in the US East 1, the VPC that your own custom VPC that you create is going to span multiple availability zones, as I'm showing here. Then, if you want to create resources such as EC2 instances, you're going to have to create containers for them. Those containers are going to be, in this case, they're going to be subnets, okay? And then the important thing to keep in mind about a subnet is that a subnet is going to be contained within an availability zone. In other words, the subnet cannot span more than one availability zone. Pretty much it's going to be contained within the availability zone where it was created. And so any resources that you create there within that subnet, it makes sense that those resources are going to be contained also within that within that subnet. So that's the main idea. And then you can have public subnets, but you can also have private subnets. A public subnet is going to be defined as a subnet that is going to be able to access the internet. Not only can any EC2 instances or whatever you place inside of that public subnet will be able to initiate traffic going out to the internet, but also it can potentially accept traffic coming from the internet into that subnet. But before I go any further, if you need your VPC to have access to the internet, you will have to create an internet gateway. By the way, in this particular case, this is not the symbol per se of the internet gateway. But if you were to create an internet gateway, that internet gateway is going to be detached, or kind of like floating. Is going to be inside of the availability zone where you create it. So if you want your VPC to have access to the internet, you need to attach the internet gateway to the VPC. If you don't attach it to it, it will be floating within the region where it was created. But again, if you need your VPC, your custom VPC, to have access to the internet, you need to attach an internet gateway. Something important here is when it comes to whenever you create your VPC, I think the first step, one of the first steps that you need to define whenever you create your VPC is what is going to be the block of IP addresses that you're going to be selecting for your VPC. In this case, I'm selecting the 10.0.0.0/16. What this means is that the first two octets, remember an octet is made up of 8 bits. What I'm saying here is I'm using the first 8 bits and the second 8 bits for a total of 16 bits, and those are going to be reserved for they're going to be fixed, in other words. So the 10.0, that's going to be fixed. Now the third octet and the fourth octet, they can vary. In other words, if I need to create subnets, I can modify, for instance, the third octet, and by modifying the third octet, I can differentiate multiple subnets. As you know, in this case, for this particular third value, remember these first two are going to be fixed. The third one, the third octet, can change, and if you think about it, you can change between the values of 0 to 255. What that means is that you can potentially could have 256 subnets inside of this subnet, inside of this in this CIDR block that belongs to the VPC, and if you do that, those VPCs, those subnets that you create, those potentially 256, they won't have any overlap between themselves if I differentiate each subnet by changing the third octet. Okay, and then if you do that, then you would have the last octet that would be that value would tell you the number of hosts that you can potentially have. So in a case like this, let's suppose for this first subnet, remember the first two are fixed. The third one, I can modify this. Let's suppose that I leave it as 0. Then the last octet, the values that it can vary, it can go from 0 to 256. Those are the numerical values that it can have. But remember, when it comes to AWS, if you have a subnet that has potentially 256 potential different values, AWS is going to take 5 of those values away from you. So instead of having 256 potential hosts that you can place on your subnet, you're only going to have 256 minus 5, that is going to be 251. But even 251 is a lot of hosts that you can place inside a subnet, okay? That's the main idea. And then if you want to get an idea as to how many subnets you can potentially have, you can go from 10.0.0.0. In this case, these two last, the third and the fourth octet, they are the ones that they can change. And the first one can change from 0 to 255, which is 256 values, and the next one can change also from 0 to 255, which gives us 256. So the total number of hosts that you could have here could potentially be 256 times 256, which is 16,000 something. I believe it's 16,000 something. But it's a large number of like EC2 instance, for instance, that you can have there. The other important aspect about whenever you create a VPC and whenever you specify the CIDR block that you're going to be using, there's going to be a main route table is going to be created for your VPC, and that routing table is going to indicate that the pretty much the CIDR block that you reserved for your VPC, any traffic that is within the values that can occur in the IP addresses in that space, again going from this value all the way to this value, any traffic that is destined for any other IP address that belongs to the same range of IP addresses is going to be considered local, okay? So, and that's going to be allowed, by the way. So it's going to be considered local, but also is going to be considered allowed. Now, the next thing that you need to understand is when it comes to the public subnet, if this is going to be a public subnet, besides knowing how to access other resources, other EC2s that are located in some other subnet, remember this is going to be considered local traffic because the IP addresses that the different devices are going to be having here, the private IP addresses that these EC2 instances are going to have here, they're going to be they're going to be in this larger range, right? So that traffic is going to be considered local. But if you want to go to the internet, the only way you can go out to the internet is going to be via the internet gateway. And this internet gateway, you can think of it as if it were a door that takes you out to the internet. You can initiate traffic for any resources that have a knowledge about the internet gateway. You can initiate traffic by these hosts here. They can initiate traffic going out to the internet. Maybe they need to access a server to download some software patches for the operating system or for any application that you have installed in that EC2 instance. But they can initiate traffic going out to the internet. And then provided that if this is going to be some sort of server, then you could potentially receive traffic that is initiated from the internet into your into this EC2 instance. For instance, suppose that this were a web server. Suppose that it has assigned a public IP address, then traffic from the outside could potentially come here. But don't forget that if you're going to accept any type of traffic, if you're going to allow any type of traffic into an EC2 instance, you need to make sure that the security group that you're going to be attaching to this EC2 instance has to allow traffic on that port for that service that this virtual machine is allowing. So if you are providing, again, HTTP traffic, you need to make sure that the security group that's attached to this EC2 instance is going to be able to allow incoming traffic from the internet on port 80. So you need to make sure that you have that setting. And then in this case, we have, by the way, in order for this public subnet to be really public, just giving it a name public doesn't make it public. You need to add an extra route in the routing table that you're going to associate with this public subnet. And we know that it's the first entry that we have here, the 10.0.0.0/16. That is the one that is kind of like the one that it inherits from the main is going to inherit that route from the main route table. But the second one, the one where you're saying I want this to be able to go out to the internet or accept traffic from the internet, is going to be the second entry. And in this case, pretty much what you're telling that subnet, if you attach this routing table, is if you need to go to, remember, in this case, what is the destination? The destination is the internet. The internet is going to be denoted as 0.0.0.0/0. If you're going to go there, use the internet gateway to go out there. Okay, that's the main idea. Whereas in the case of if you have a private subnet, the main thing about the private subnet is, as opposed to the public subnet, these ones are going to have private IP addresses. I'm sorry, they're going to have public IP addresses. Both of these two are going to have private IP addresses, but this will have a public IP address. And that's how it can be reached from the internet. But this other one, this one is not, we don't want to allow any EC2 instances placed inside a private subnet to be directly accessible to the internet. We also don't want them to be able to directly be able to go out to the internet by using the internet gateway. We don't want that. Also, they don't have any public IP addresses assigned to them. But what happens if this EC2 instance wants or needs to access to download patches for its operating system or for any applications that it has installed on it? What you're going to have to do is you're going to have to create this virtual device, which is going to be called the NAT Gateway. And the main function of the NAT Gateway is that it can allow any EC2 instances that need to request, that need to be able to send messages to the internet or initiate a session with some server out there on the internet, this device is going to allow us to do that. But in order to do that, you need to place the NAT gateway inside the public subnet. Okay, so that's important. That way, the NAT gateway will be able, because it's placed inside a public subnet, and because the subnet has an entry that says if anything that's placed inside of it needs to go to the internet, it's going to be using the internet gateway. This NAT gateway will be able to access the internet. So then what is going to happen is if this EC2 instance needs to download some patches, some operating system patches or application patches, pretty much what it's going to do is going to be able to do that, but it will have to place the request with the NAT gateway, and then the NAT gateway will be able to go out to the internet, request whatever updates this system needs, and then be able to, once the response gets sent by whichever server we contacted out there on the internet, the traffic will be sent by that server into the internet gateway, into the VPC, into the NAT gateway, which was the one that originally the request, and then the NAT gateway will be able to send the traffic back to whoever initiated that request, put that request by the NAT gateway. As I mentioned before, one way that I like to explain public subnets versus private subnets is if you're an adult, if you live in a household where there's adult people and there's children, you can think of adult people as being kind of like being in the public subnet, which means they can go out the house as they please. They can also accept visits if they want to, whereas the ones here in the private subnet are the ones that are protected. Who do you protect at home? Like if you live in a household, you want to protect the children, right? So if this were, in this case, whatever is placed in the private subnet is very similar to a child, and if this child needs to request something from outside, what this child is going to do, or what these children, if there's multiple of them, they will be able to go out to the internet. Well, actually, the message that they need to send out to the internet can be sent out, but they need to use the services of the NAT gateway. So this is like a nanny, if you use that analogy that I was using. The nanny is going to be an adult person, and the nanny will be able to request stuff from the outside whenever something gets, whenever that thing that was requested it comes back, it will come into the NAT gateway, or kind of like the nanny, if you want to use that analogy, and then the nanny will be able to give the item to the kid that requested it originally. Like I said, that might be an oversimplification of how things work, but I think it to some people it makes sense. But if we were to look at the NAT gate, if we were to look at the routing table that is going to be attached to this private subnet, in order for it to be able to access, to be able to communicate with the NAT gateway, so that the NAT gateway can put requests on some server out on the internet, this is what the routing table of the private subnet is going to look like. The destination, well, first of all, it's going to inherit the main route table, which is going to be any traffic that goes to 10.0.0.0/16. I forgot to add this here. It should have looked like this one here, 10.0.0.0/16. So I should have that here. That's going to be considered traffic and should be allowed. But if this EC2 instance needs to initiate a communication that's going to go out to the internet, if they need to get some access to the internet, they need to use the NAT gateway, so that the NAT gateway puts the request on their behalf, and then whenever the request comes back in, it will come into the NAT gateway, into the VPC, into the public subnet, and then the NAT gateway will deliver the file, the information, whatever it is that this EC2 instance required or requested. But that's the main idea about this, and next step that I'm going to do is I'm going to proceed to the implementation of creating all of this. By the way, some of the Some of what I missed what I did not include here, but it's going to be part of this that I'm about to do is remember that EC2 instances, they need to have uh, attached a security group because we need to protect them. So if this is going to become a web server, or if it's just, let's suppose it's not a web server, suppose it's just an SSH server, we need to allow traffic on port 22 because that's the port that is used for SSH protocol. But if I were to install web server software on this machine, so this becomes a web server, then I would have to open port 80 so that that traffic can come from the outside into this EC2 instance. Any traffic that comes from the outside into your VPC, that's going to be called inbound traffic. So I'm going to have to modify the inbound rules for this the security group that I will attach to these EC2 instances. And also there is something called the when it comes to a subnet, the equivalent of a firewall that you attach to a subnet is called the NACL. Most of the time, whenever you create a subnet, either public or private, it's very common to leave the network access control list, or NACL, the way that it was given to you. So you're not going to, most of the time you don't modify the settings of it. If you require extra security, you might want to add some sort of rules, but in this case you're not going to be doing that. Okay, so I'm going to proceed in a moment to start with the lab. Okay, so the order in which I will be creating resources here are going to be, well, first of all, I need to select the region where I'm going to be creating my resources. I think most likely I'm going to be using US East 1. After I select that region, I'm going to go to the VPC service and I'm going to create a VPC. Once I do that, I can create separately an internet gateway, which I will later attach to the VPC. So then I can have that. And then in one of the availability zones, I can create a couple of subnets that I will call these names that I'm giving here. And then I will be creating a couple of routing tables. One that's going to be used by the public subnet. I will attach that routing table to the public subnet, and then I will create another. Well, in order for me to create a NAT gateway, I first need to get an elastic IP address for it, because we don't want the public IP address of this NAT gateway to change. So we're going to assign it a static public IP address, and the only way that you can get a static public IP address on AWS is by means of an elastic IP address, and that's why we want a public IP address that doesn't change. And then once I do that, once I have this ready, I can modify the routing table of the well, first of all, I will modify the routing table of the public subnet, so that it includes this route, so that it will be able to use the internet gateway. And then when it comes time for me to create the routing table for the private subnet, I will make it point to the NAT gateway. But I first need to create a NAT gateway, and but that's the main idea about that. And in order to test the functionality of my EC2 instance, I will make sure to install some sort of software, server software on it, so that I will be able to access the service that is providing us. Okay, so in this case here we have the management console, where I will be creating those resources. So remember, the first thing I'm going to do is going to be create a VPC. I type in VPC here. Once VPC displays. What I'm going to do is I'm just simply going to create a VPC. Create VPC. I just want to create a VPC only. There are ways in which you can create there's kind of like this wizard which can create multiple subnets, but in this particular case I'm going to do multiple things. I'm going to create it from scratch. By the way, right now I'm located in the US East 1, which is where I want it to be. So I'm going to say VPC only. The reason why I say VPC only is because I'm going to be creating these ones one at a time. I can call this one, I could call it just VPC. Doesn't matter, I could call it my VPC. Now I need to specify the CIDR block. I can use 0.0.0/16, just like I did in my in what I was showing you. The tenancy refers to whether you want to have your VPC being placed in a by default is going to be that is going to be placed in a shared tenancy, which means it's going to be shared some servers with other AWS customers. If you want to dedicate it, that's going to cost you more money. So in this particular case, I wouldn't suggest you do that, especially if you have a paid account. So let me call it, actually I should call this lab VPC. And then I have lab VPC. I'm going to use IPv4, by the way. I'm not going to use any IPv6 at all. So create a VPC is as simple as just specifying the CIDR block, giving it a name, which is a name tag, which is optional, and just creating it. Now my VPC has been created, so you can see how simple that was. Now something that I can do, because I want to create everything from scratch. Well, I have a lab VPC and I have I have two VPCs. They have the same CIDR block, but that doesn't make any difference. The one that I just created was this one, the lab VPC. The work VPC was created by who knows who, but it wasn't me. Okay, so pretty much I need to pay attention to this VPC ID. AWS likes to keep track of VPCs by their ID. So just remember, it's going to be 250. Those are the last 3 digits. So right now the next step that I can do is I can create the Internet Gateway. So let me create the Internet Gateway so then we can have access to that. I have some other Internet Gateways here, but in this particular case I don't care about those ones. I'm going to be creating my own Internet Gateway. So in this case, this is going to be lab Internet Gateway. Lab Internet Gateway. And then this is going to be the name, and just by doing it like this, I'm creating it, okay? Now, remember at this point, given that I created the Internet Gateway, this Internet Gateway is just going to be floating. It's just going to be floating there in this region. If I want to use it with the lab VPC, I need to attach this Internet Gateway to it. And you can see that AWS is telling me, hey, do you want to attach it to a VPC? Yes, that's what I want to do. But you need to do it explicitly, in other words. And here you are, here's the lab VPC. You might wonder, why did the work VPC didn't appear here? The reason is that work VPC most likely already has an Internet Gateway attached to it. That's why we don't see it here. Okay, so I attach it. Now, by doing that, I just attach the VPC to the I just attach the Internet Gateway to the VPC. So my VPC now has an Internet Gateway attached to it. The next thing I'm going to do is I'm going to create a couple of subnets. There's a lot of subnets here. All of these subnets, as you can see, all of them belong to the same VPC because all of them end in 83D. They all belong to the same VPC. Something interesting about these subnets is that they're a /20. This /20 is different than the /24 that I will be using. Well, It's different than the /16 that I use, by the way, for my well, actually, this refers not to the CIDR block of the VPC, but rather it's going to be the CIDR. This is the CIDR block for the different subnets. So what this means is that one of these subnets can potentially have 4,091 potential hosts, but that's way too many. I want something smaller, so I'm going to be use something like this, like a 10.0.0.0/24, so that I can potentially have this number of hosts. But so the main idea here is going to be that I'm going to be creating my first subnet. I need to specify what VPC I'm going to use. The one that I'm going to use is the lab VPC. Remember that ends in 250. You can see that in this particular case, provided that you give a label to your VPC, you don't need to remember the number of the VPC, the last few digits. Instead of it, because you gave it a label, it's easier for you to identify it, okay? Now it's asking me what name I want to give this VPC. I'm going to use the same name that I'm going to call it subnet public one. Subnet public one. Okay, so that's going to be the name. The availability zone, remember in this particular case, I said that I was going to place it in US East 1A. So this is asking me which availability zone do you want to place it in. Well, I want to place it in US East 1A. And there it is. Now it's asking me for the CIDR block that I'm going to use for this VPC. The easiest way for the way that I can create different CIDR blocks is going to be, I can start, like, for instance, with one. I can use 10.0.1.0/24. What that means is 8 bits here plus 8 bits here plus 8 bits here. That's 8 times 3. That is 24 bits. Though these 24 bits are going to be set aside for the network ID. And then I will have this last octet for my hosts. In this case, I can potentially have 251 hosts, which is more than plenty for what I need. But in this case, I started with this .1.0, and then this is the name, and then I just create my public subnet. And you can see how easy that was, right? My next one, the one that I'm going to create, the private, is going to be, by the way, let me copy this. The other one, the reason why once I create my private subnet, I want to use this format that I use for this one, but except that I'm going to say public, and then I'm going to use 10.0.2 for that subnet. The CIDR of that subnet is going to be the ID part, the network part is going to be 10.0.1, and then I create my subnet. Okay, that the first one has been created. The next thing I'm going to do is I'm going to create my second subnet, again in the same LAT VPC. Now I need to indicate the name, and then, like I mentioned before, I want to use the same format that I use here, private. And again, I want to place it in the same availability zone as I placed my public subnet, right? It's going to be in the same US East 1A. Now, once I do that, I need to specify what the CIDR block is. So it's going to be 10.0. I cannot use 1. If I try to use 1, that's going to be a problem. The one is already in use. I need to use 2.0, okay, /24. So that my last, my host will be only, they will be using the last, they're going to be using the last octet. So I can potentially have 251. So now that I do this, I create the subnet. And by doing this, I just created the two subnets that I wanted, okay? So you can see there is subnet private 1 and subnet private 2. If I want to see them together, I guess I could put them in order with respect to the VPC, and I ordered them with respect to the VPC name, and these two are 250. So here are the two ones I need. Okay, so if we go back to the diagram that I have here, so far I have the VPC. I attached the Internet Gateway. I created the public subnet 1 and the subnet private 1 also. Now I need to start dealing with the routing tables. Without the routing tables, these two subnets would be considered private pretty much, because they don't have at least this one doesn't have a way to go out to the internet. So what I'm going to do next is I'm going to well, let me create the NAT gateway first. Remember, for the NAT gateway, I need to create first an elastic IP. So here is the elastic IPs, and I don't have any elastic IPs here, it seems. So I'm going to create one. It's going to be created in this region, and pretty much that's I'm going to add a tag to it so then I don't forget. So this is going to be lab NAT Gateway. Okay, let me actually use lab NAT Gateway. So that's the name that I'm going to give it. Okay, so it's being created. This is the value it's going to have. So the next thing that I need to do is I don't need, at this point I haven't created my NAT gateway, so I cannot associate this one to the NAT gateway yet. By the way, this is by the way, the name that I gave it here, maybe I should have called it lab NAT gateway, maybe something like elastic IP. Okay, that way it makes sense. Lab gateway, and this is its elastic IP. Okay, so now I need to go to create the NAT gateway. If I want to do that, here are the NAT gateways, and then I'm going to create a NAT gateway. So it's going to be called lab. I can select something like NAT gateway. Okay, lab NAT gateway. I need to specify the subnet. This is the subnet where it's going to be placed. If you take a look at this, it's going to be placed in public subnet 1. Okay, subnet public 1. This is what it's going to be, placed inside of. So I need to do that. It's going to be in the public subnet public 1. That's where it belongs. Now I need to specify the connectivity type. Is it going to be public? In this case, I want it to be public because I want it to have access to the internet. And then I need to specify, because it's public, I need to specify what I need an IP address, elastic IP address. And here's the one that I just created, so I'm going to associate it with that NAT gateway. Okay, so now I click create NAT gateway, and there it is. So right now I have my NAT gateway on that public subnet. Now if we go back to my diagram, so I have my VPC, I have my internet gateway, I have my subnet public 1, I have my subnet private 2, I have my NAT gateway. What I need right now is to start modifying routing, start dealing with routing tables. Okay, I'm going to start with this one, with this routing table that I'm going to be associating with subnet public 1. So if I come here, I need to go to routing tables. This is all of these options that I have chosen here. The reason why I can find them so easily. All of this is part of the networking section of AWS. That's why all of these features that I'm looking for are here. But I will not find I won't find an EC2 instance here because that's not part of the networking. So let's go with the routing tables. And then what I'm going to do is I'm going to create a route table. the name of my route table is going to be lab, and I want the name to be associated with, so let me create RT, lab routing table, and then it's going to be for subnet public 1. Okay, lab routing table for that. Okay, so now it's asking me what VPC I want to use it with. Again, I've been working with the lab VPC, so I'm going to use the lab VPC. Now once I've done that, what I need to do is here's the name, so I create the routing table, and as the routing table has been created, you can see that it inherited the local route for the CIDR block that it belongs to. Now I'm going to edit this routing table, and what I'm going to do is I'm going to add a route. The route that I want to do is if I want to go to the internet, I need to access it by means of the if I want to access the internet, I need to access it by means of my lab internet gateway, right? So in this case, what I'm going to do here is I need to specify how I'm going to get there. It's going to be by means of an internet gateway. And then I need to specify the ID of it. In this case, it's going to be this one, lab internet gateway. And then I'm going to save my changes, and that is that. Okay. Now the routing table, this routing table has been created. Now what I still miss is I need to associate this routing table with this subnet. If I don't do it, that will be like a floating routing table, but it's not associated with a subnet. So I need to associate it too. So in order to do that, let's find an action to try to associate this. You can see subnet associations. Here is that section that I need. I need to specify that I want to associate this routing table with it's going to be associated. This routing table here is going to be associated with subnet public 1, okay? Public subnet 1. The reason why I don't see any of the other subnets that I have in, as you saw that there were a lot of subnets. The reason why I'm not able to see all of the other subnets is because I specified that I'm working with the lab VPC, and the lab VPC only has 2 subnets. That's why I'm only seeing these ones, because I indicated that I was working with my lab VPC. So right now I just created that association. I just need to save it, and that routing table has been associated. Now I go back again to routing tables, and I'm going to create another routing table that's going to be for the private subnet. In this case, I want to copy this name because I want to use the same kind of like naming convention for my private subnet. Okay. And then I create another routing table. This is going to be similar in name to the other one, except that this is going to be private. The other thing that I need to do is, give me a moment. Okay, the other thing that I need to do is, okay, so I'm creating the routing table for the private subnet. So I need to select my lab VPC, that's the one that I've been working with. And then I just created a routing table. The routing table has been created. And I associate it with the lab VPC. And remember, the lab VPC only has 2 subnets. So in this case, I'm inheriting this one. This one we received it from the main routing table, and now I just need to edit the routes. I'm going to add a new route. The route that I'm going to be adding here is going to be the route that says if you want to go to the internet, if you're in the private subnet, and if you want to go to the internet, go out through the NAT gateway. Okay, so that's what I need to specify. So in this case, I want to go to the internet. How do I want to get there? Well, I want to use a NAT gateway. What NAT gateway do you want to use? Is going to be this one. And then I'm going to save my changes, and by doing that, I have just associated that I have just associated that I just made the association to well, actually, let me see. I haven't associated it yet, by the way. I haven't created the associated. I just created the routing table and the entries. I just created the routing table and the entries, but I still haven't associated with this subnet. Don't forget that you need to associate them. Just creating them doesn't make the association. That's why I need to come here and I need to say edit subnet associations, okay? So, and I'm going to be associating this one to my private subnet. And then I'm going to save the associations, okay? And by doing this, I just finish associating that new routing table, the private routing table, to the private subnet, okay? And now the next thing I need to do is pretty much I just need to start creating a couple of, I just need to create two EC2 instances. One is going to be here, and the other one is going to be in the public subnet, and the other one is going to be in the private subnet. Something important that I need to mention here is whenever you create your subnets from scratch, there is a setting that I need to change in my public subnet so that anything that I place here, any EC2 instance that I place here, is going to receive a dynamic public IP address. I need to change that setting. If I don't change that setting, I need to do it with everything that I place here, and I want to be taken care of by itself. Okay, so what I need to do is I need to go to my subnets, and I need to modify the again, I need to modify the setting, the properties of this public subnet, so that it allows me to, so it will give out IP addresses by default. I don't think that we can see that here. Oh, this is the part. Auto assign public IP address for by default is set to no. I need to change this to be in yes. So anything that I place in my public subnet and EC2 instance is going to have associated. Just by placing it there, I want it by default to be assigned an IP address, a public IP address. So this is the setting that I need to change. So what I'm going to do here is I'm going to go here, and I need to find out. It's going to be, I believe it's going to be part of the subnet settings. And then you can see here, auto assign IP address. In this case, it's referring to public IP addresses, okay? It's not referring to private IP addresses. Anything that I place in either a private or a public subnet will have any EC2 instance that I place inside of a public or a private subnet will get a private IP address. But a public one, I need to make sure that this setting is checked, and then I click save. The next thing I need to do is so pretty much any EC2 instance that I create that I place in my public subnet now, because of the change that I made, is going to receive a public IP address. You can see it here. Auto assign public IP address. The one that I highlighted is the public one, and the default that I configured is going to be yes. So now let me create a couple of EC2 instances. So I need to go to EC2, and I go to the EC2 service. Remember, if you want to have a shortcut of any service that you use often, click this, so it will appear over here, and then you don't need to search for it. You see, it just appeared there. There it is, okay? So I can access it from here. So now I'm going to create two EC2 instances. I don't think I have any EC2 instances running in this lab environment. Oh, I did. That's not good. That means that there is some money being spent on this account. I don't want that. So I'm going to terminate this EC2 instance. and it was a Bastion host. By the way, a Bastion host is used if you need to access EC2 instances that are located in a private subnet. A Bastion host is an EC2 instance that you place in the public subnet that you can access via SSH if it's a Linux one, a Linux system, and from this one you can jump onto the you can do an SSH session into the private EC2 instance into the EC2 instance that is located in the private subnet. Okay, but I just got rid of it, so then I don't need to worry about getting a bill for that. So now it's terminated. So now what I'm going to do is I'm going to go to instance types. I'm going to go to instances, I'm sorry, and then just launch instance. And I'm going to launch an EC2 instance. By the way, this EC2 instance is going to end up being, I'm going to make it a web server, okay? So I'm going to call it lab. It's going to be lab web server. Okay, and then I'm going to specify that I want to use Linux 2. This is about a free tier, 64 bits, fine. The family T2 micro is perfect for that. The key that I'm going to use, I think I might use my own key because I'm not sure whether I have access to that key. Just in case I don't have it, I'm going to call it lab. Let me see, what do I call it? Let me see. AWS lab. And in this case, I can select either the PEM or the PPK. I can use either one of them. If I use this one, I need to use PuTTY. If I use this one, I don't need to use PuTTY. Because I don't like to use PuTTY, I can use this one, okay? But you can, this is something that you need to be aware of. If you're using Windows 10 or higher, you can use the PEM key. I'm going to download this one just to make my life a little simpler. And it's being started to being downloaded. Now I have it. AWS Lab, that's the name I gave it. Now here comes the part related to the security groups. By default, this EC2 instance is going to allow SSH traffic from anywhere. But I said that I want this machine to be able to have access to it from HTTP traffic. So I'm going to put a check mark here. And let me see. Oh, sorry. That's a very important thing that I forgot to do. This is something you have to be aware of. Remember that if I don't specify what VPC an EC2 instance is going to be launched, it will be launched by default into the default VPC. And I want to use the lab VPC. Remember that the 250 something was the ID for my lab VPC, and this is not a 250 or something like that, so I'm going to edit these settings. You see, it was going to try to launch it into the default VPC, and this is not desirable in this particular case. Okay, this is the 250 that I was telling you about. It's the lab VPC. That's where I want my EC2 instance to be placed into. And then I want to place it in my public subnet. So it's going to be subnet public 1 because this is a web server, so I want it to be accessible from the internet. So it's going to be subnet public 1. Remember the setting that where I specified that what it was going to be for the auto-assigned public IP address. The reason why this enable is appearing here is because by default, I wanted it to be enabled when I changed that setting. Otherwise, it would have been disabled, and I would have to manually change it to the other one, okay? Now, I'm going to create a new security group. I'm going to call it web server security group. Well, I'm going to call it lab web server security group. By the way, I'm not allowed to have, as you can read here, the security group will be added to all your network interfaces. The name can't be edited. Valid characters, well, they allow spaces, so I have no problem. There's no problem with this. I can have these spaces here. And then I can call it lab web server security group. And I'm going to allow SSH. That's fine. As I also want to allow traffic on port 80. So that's something that I need to take care of. Okay, I can do it afterwards. Add security group rule. Let me see. Yes, I'm going to add a security group. That security group rule is these are inbound security groups, by the way. These are any traffic that is coming into my EC2 instance from outside, from outside. Any traffic coming in. So it's going to be HTTP. There it is, HTTP. It populates, it knows that it's going to be, the protocol is going to be TCP. This is layer 4, if you remember. This is part of the, this is the TCP protocol, and the port is 80. So just by selecting the protocol name, it will populate the type of, whether it's TCP or UDP. In this case, it's going to be TCP, and then the port number. And then I want the source to be to come from anywhere. Okay, I want anywhere. Anywhere is denoted by 0.0.0.0/0, and then this is not going to be SSH. This is going to be port 80. This is going to be HTTP traffic. Okay, so I have my port 22, and now I have my from anywhere, and I have my port 80. And that's pretty much it. Let me see. It says that a security group has been added with the same range. Well, I only have 22 here, and I have, let me see, security group rule 2, TCP 480. Security group, no, that seems to be fine. Advanced configuration. Well, anyway, we'll see what happens. If it gives me a problem, I'll have to do it manually on that EC2 instance. The next thing I need to, well, I'm going to leave the 8 GB drive, and now the next thing I want to do is, because I want this machine to be running a web server, I'm going to find a script that I need to enter here. So then that script executes, it installs the HTTP, Apache web server, and also starts the service. It enables the service. Yeah, basically those are the ones those are the main things that I need to, and also I need to create a very simple web page. So I'll be doing that in a moment. Okay, so I have the script, so I'm going to paste it here. So this is going to be a bash script. So it's a bash script. The first line, what it's going to do is going to update the operating system. The next line here is going to, well, this is using the package manager, that's GWY, that was being used here. In this other line, I'm going to be installing package manager, installing the Apache web server. Then I'm going to start that service in this session, and then I'm going to enable it so that in the future, every time this machine restarts, this will start automatically in the background. And then I'm going to create a web page, a very simple web page. Pretty much I'm redirecting the output of this echo command. I'm redirecting it to a file, and that file happens to be the index.html web page, which is going to be, whenever I connect to my web server, that's the web page that I will be accessing. And by the way, what I'm doing here is I am doing the output of this command in Linux tells me what the host name of a system is. So I'm going to, whatever the host name of this system is going to replace all of this. Okay, but that's the main idea about this. And right now that I have done this, the next step to do is just to launch the EC2 instance. Hopefully I haven't made any mistakes and this will work just fine. Yeah, everything looks fine. So I'm going to launch my EC2 instance. By the way, this is going to be the one that's launched in the public subnet. Let me see, is there a problem anywhere? Why didn't it? The security group rule with the same protocol. I don't remember creating a second. Well, I'm going to have to delete this one. I don't see where that other rule is, but I'll have to take care of that once I can. Fortunately, I can modify the security group afterwards. Okay, so we're going to be waiting for a moment for this EC2 instance to be launched. By the way, what I can do right now is I can create the EC2 instance that is going to be in the private subnet if I wanted to. I guess I can do that. That way I can show you that it works. So I'm going to launch a second EC2 instance. This is going to be, I guess I can call it a lab, and it's going to be private EC2 instance, right? Lab private EC2 instance. I'm going to select this. I'm going to select the instance type. I'm going to select the T2 micro with 1 GB of RAM. The key is going to be the one that I created, AWS lab. The network settings, remember that if you forget, it's going to be placing your resources in the default VPC. So remember to change it to your custom VPC, unless you want it to be launched in the default VPC. And then I want this to be in the private subnet. So this is subnet private 1. This is where I want it to be. In this case, you can see that by default, the setting of the auto-assigned public IP address is going to be disabled. Okay, it's going to be disabled. And then the security group, in this particular case, I can just use any security group. Pretty much I just want SSH traffic for this machine, pretty much. So this machine is called, okay, let me call it like this, copy. So it's going to be, this is not going to be it's going to be a security group for this thing. And then I'm going to replace this by this, and I'm going to allow SSH. In this case, I'm not going to be accessing this machine anyway, so it doesn't matter. I'm not going to add anything in the script, so I'm going to launch this one too. And I guess that's pretty much it. So let's take a look at our instances that are currently running. Well, this one is in the initializing process. It hasn't become ready. As soon as it becomes ready, I should be able to try to connect to it. I guess I will have to wait a few more minutes. But pretty much what is going to happen here is with this one, which is going to be my web server. As you can see here, it has been assigned a unique ID. It's going to be its identifier. You can see the instance state is in the running state. You can see the instance type. You can see that it's being initializing. It's initializing. There's 2 status checks that need to complete before this machine is ready to be accessed. You can see that it hasn't even passed a single check. You can see that I placed them in this availability zone as part of this region. But whenever you add a letter at the end of the region name, that means that that's the availability zone. You can see that this one has assigned a public IP address. This is the one that I will try to connect to. And then these are just the security group. Oh, by the way, because I had a problem with the security group that was telling me there was a problem. If I try to connect to the web server, as soon as it's ready, it won't work. Reason being that oh, it passed the two checks, so this is ready to be accessed. So if I right now I don't have any settings here. As you can see, there's nothing here. I need to select an EC2 instance that is running from here in order to get its settings. So if I copy this address here, and then if I try to access it, we're going to see what happens. Okay, so I'm going to open a new tab in a moment. Okay, I just open a tab, and now I'm trying to go to the web server. As you can see, this is going to time out. The reason why it's going to time out is that there is no port 80 allowing traffic into this EC2 instance. Okay, it's not connecting, not connecting. It gave up. It couldn't reach. What this is doing is, this is called a timeout, in that it tried, and nothing happened. In a case like this, the reason why it times out is because in many cases, whenever it times out the way that it did here, that's still trying and trying and trying, it just gave up. Pretty much this, in a situation like this, when it times out, very likely it's going to be your security group that didn't allow the traffic. Okay, so let me fix. You see, it's still trying to see if it can access it. So what I need to do is I need to go to the security group of that EC2 instance, and I need to fix, let me see, the security group. Yes, it's going to be this one. This one is the one that I need to modify, and I need to modify the inbound rule. Remember that I had a problem with port 80, and I didn't add it. I only left the SSH, so I have only SSH here. So what I need to do is I need to edit the inbound rules. These are usually the only ones that we modify in security groups. I need to add a rule. The rule is going to be that I want to accept traffic HTTP. It's going to be port 80. I want to accept traffic from anywhere, and this is going to be web traffic. And this was SSH traffic. And then I just save the rule. Now that the rule has been open, well, I'm assuming also that the web server is up and running. In order to do that, I will have to connect to that EC2 instance. But let me go here. Let's see if we can connect to it. Oh, there is the web page. It worked. So I was able to access the web. Oh, well, the problem is I supposedly created a web page that was going to display. This is the default web page when you don't define your own web page. So there was a little problem in my script, because this one that I was using, there was a problem somewhere, and so it failed. Pretty much it failed. So that this page, for whatever reason, wasn't created, I assume. But the server, all of these parts took place. It updated it, the operating system, it installed the web server, because by default it's not installed on an EC2 instance. It started it, I assume that it enabled it, but there was something here that it failed at doing that, and then that's the thing. Oh, I can see what it was. There was this was missing, and you can see I started it here, but I deleted it for whatever reason, and that's why, yeah. So then, yeah, that's why the web page didn't appear. But at least I figured out why that happened. Now, if I go to the second EC2 instance, the second EC2 well, the problem with the second EC2 instance is I cannot access it unless I use something called a bastion host. Yeah, I won't be able to access that other one. So let me just quickly, let me try to see if I can connect to that EC2 instance that I created, at least to the one that's to the web server. Let me see if I can connect to it via this is the lab web server. Let me see if I can connect to it by using this. Most of the time this is disabled in this particular type of labs, but let's see if I'm able to make a successful connection. Establishing connection. Oh, I connected to it, which is great. Okay, so this is connected. So right now I can do something like system, let me see. I need to check the status system CTL. What I'm going to do is I'm going to check the status of the Apache web server. So what I want to do is I want to find the status. And for that I need to use system CTL, and then I need to specify, I need to indicate status, and then I need to specify what daemon I'm trying to check. HTTPD, that's the one that I'm running. In this case, we can see that it's active, so it's up and running. That's the status of it. Okay, but that's pretty much the lab. Like I said, the problem, unfortunately, when I created this script, I mistakenly erased this thing. That's why this didn't work. I did not end up creating this file because this probably just echoed all of this, but it didn't create the file. And I wanted the output of echo to be redirected to a file in this location, but unfortunately that did not happen, and I guess that's that. Okay, but this is pretty much as we can see, this worked fine. Actually, if I try to ping, oh, let me see. If I try to, well, I was trying to think what happens if I try to ping that other system. The problem is that the private EC2 instance that I created doesn't have ping enabled, so it wouldn't reply unless I change that, of course. So let me see. So the IP address of that other EC2 instance is this one, by the way. It's only going to have a private IP address. It doesn't have a public, but this is the public IP address. So like I said, if I try to ping it, I don't think it's going to reply, but let's just see. Just ping, let me see. I need to, okay, let me see if I can ping it. I don't think I can ping it. I don't think it has pinging enabled. It's not allowed, it's not going to respond. If I want to fix that, what I can try to do is I can try to enable, I can go to the security group of this EC2 instance and change, and try to change the security group to allow pinging. So this is the security group, and I can try to add edit inbound rules, and I can select IMCP. This is pinging, and I can say that I want to allow pinging from I can use the same. I can use 10.0.0.0/16. That's the CIDR block of my VPC, pretty much, which means anything that's in my VPC, I'm going to allow it to reply to it. So this is going to be ICMP. That's the name of, when it comes to pinging, that's the protocol. ICMP, that's the name it's called. So this is for replying to ping requests. Let's see if that does the trick. You see, right now it's replying, that the ICMP is replying, which is a good thing. So that machine is replying to me from the, in this case, this is the console of this is the console of the web server that is in the public subnet. So pretty much everything is working, I would say. I wasn't able to log in. I wanted to log into this EC2 instance, but unfortunately I cannot do that into the one in the private subnet. But I think everything, I think other than that, and the fact that I made that mistake here, everything worked fine. Okay, so pretty much what I did in this lab was to recreate this. I created all of everything that you can see here was created in this lab. Okay. So I hope that you have liked this video, and that's it. Thank you very much for the attention. Bye.